NumPy is a linear algebra library in Python. It is an important library on which almost every data science or machine learning Python packages such as SciPy, Matplotlib, scikit-learn, etc. depends on to a reasonable extent. NumPy is very useful for performing mathematical and logical operations on arrays. It provides an abundance of useful features for operations on n-dimensional arrays and matrices in Python. So why should we use NumPy when we have Python list? The reason is lists are more expensive in terms of memory and speed. On the contrary, NumPy arrays are fast and consumes less memory, plus it is more convenient for working with arrays, which I will prove in a second. Let's switch to Jupyter Notebook. First we have to import the NumPy library and also import time and sys for time and memory calculations. Create a Python list using the range function. Now print the memory consumed by calculating the memory assigned for a single integer and multiply by length of the array to get the total memory. Similarly, we use the same concept for NumPy arrays and print out the results. As you can see the difference in memory consumption, which will be significant while working with large amounts of data. Next, let's see the speed of operation by calculating the sum of two lists. Assign 1 million to size variable and create two sets of Python lists and NumPy arrays. Now assign the start time to the start variable. We will use zip function to calculate the sum of two lists. Finally, print the difference between the current and start time. Taking sum with NumPy arrays is more easy as we have to just add the two arrays and again take the time difference. As you can see, NumPy operation took less time, so I have proved my point about NumPy's efficiency. It's time to learn about it. First we will learn how to create a NumPy array. So let's import NumPy as NP. We can create a row vector using np.array method and pass a list with a single row as an argument. Vectors are nothing but single row or single column array. Similarly, we can create a column vector by passing a 2D list with only one column. Next we will create a matrix by passing a 2D list with multiple rows and multiple columns. In this case, it's a 3x3 matrix. Sometimes it is necessary to create array of ones and zeros. We can use the np.ones method and pass an integer to create a row of ones. Similarly, we use np.zeros and pass the integer to create row of zeros. If we want two-dimensional array of zeros and ones, we have to pass a tuple as an argument. Here we create a 2x2 matrix. Next we can create an identity matrix using the np.I method and pass an integer which defines the dimensions of the matrix. Here it is a 3x3 matrix. We have already seen np.arange method which creates an array from start integer to the specified end integer. Note that the end is excluded. We can also pass the step size as a third argument. Finally, we have the np.linspace which takes start, end and size of the array as an argument. Here it will create an array of 15 elements which are equally spaced from each other, starting from 1 to 3. So these are some of the ways by which we can create an array using NumPy. Now let's learn how to get some of the important properties of a NumPy array. For example, shape of the matrix or dimensions. Let's create a matrix using the np.array method in order to get the shape of the matrix. We use the shape property on the matrix object and it's 3x3. To get size, we use the size property which gives the product on the number of rows and columns. And lastly, the dimensions of the matrix object are provided by the endIm property and we know it's a two-dimensional matrix. Element access in NumPy arrays is fast and simple. Let's initialize a row vector and matrix for working with our examples. We can simply access an element by mentioning the position of the element inside square brackets. So row of 2 gives us the third element of row vector as NumPy arrays are 0 indexed. Similarly, for a matrix, 1, 1 represents second row, second column, that is 5. By simply mentioning a colon, we'll return all the rows and column elements. Now colon 3 on row vector will give us the first 3 elements. And similarly, 3 colon on row vector will give every element after the third element. Row of -1 will return the last element of row vector. Using the colon notation, we can slice a matrix. Here we select first 2 rows and all columns of matrix. In this example, we have selected all the rows and selected all the columns between 1 and 2, excluding 2. Next, we will look at reshaping of NumPy arrays. Initialize a 3x3 matrix. We can use the reshape method on the matrix object where first parameter is number of rows and second is number of columns. This will convert the 3x3 matrix to 9x1 matrix. The parameters can take a wildcard -1 to say take as many columns or rows needed for reshape. Now if we pass a single parameter, it will return a 1D array of specified integer. We can also use the flatten method to convert a matrix into a 1D array. Finally, reshaping can be little tricky, so make sure you have passed the right parameters. NumPy provides us with some utility method to perform some of the common logical and arithmetic operations. We can get the largest element of a matrix by using np.max method, and similarly minimum by using np.min method. Now let's talk about access in NumPy arrays. Access equals to 0 represents a column and 1 equals to a row of an array. Therefore, by passing the access value, we can get the max elements in each row or column of an array. np.mean gives us the mean of a matrix. np.std and np.var gives us the standard deviation and variance of a matrix. If you don't know about standard deviation, it is the amount by which an element varies in the matrix. There are many more methods available for us which cannot be covered due to time restrictions. You can find them inside the NumPy docs for further reference. Element-wise operations such as addition, subtraction or multiplication is very simple using NumPy arrays. To add two matrices, we can simply use the plus operator or we can use the np.add method for element-wise addition. Similarly, for element-wise subtraction, use minus operator or np.subtract method. Finally, element-wise multiplication is done using the multiplication operator. Note, this is not the dot product. To perform dot product, let's create two vectors and use the add symbol or np.dot method to calculate the dot product. Some of the matrix operations such as inversion of a matrix or determinant can be calculated using the NumPy library. To take the transpose of a matrix, we can use the np.transpose method or the t property of a matrix which returns the transpose of that matrix. To calculate determinant, use the np.lineage.det method. Similarly, we can calculate the rank of a matrix or inverse of a matrix using the np.lineage.matrixRank and np.lineageIn respectively. Finally, we will look at generating random numbers in NumPy. To create a one-dimensional random array, use the np.random.rand method and pass an integer as argument. For 2D array, pass argument for row as well as column. Here we create an array of 5 rows and 4 columns. The np.random.random method gives random samples of Gaussian distribution, that is, on plotting the elements we would get a graph of Gaussian distribution. In order to generate random integers, we use the random.randinit method. By passing a single parameter, we will get a random integer between 0 and the parameter passed. We can also specify the starting parameter, or we can generate a random array of integers by passing the third parameter, which specifies the size of an array. Note that the end parameter is excluded in all three cases. Sometimes we want to repeat the random behavior so that we can get a predictable result on the machine learning algorithms. So we set the seed, which can be any random integer. Now if we generate a random number, it will give the same result each time we execute the random method. So I will be stopping here, leaving you to dive in deeper. Most of the time you will be building on these basics to create a complex algorithm. You can refer the docs for more information about the library. I will be continuing on this playlist to make tutorial on other important Python packages. If you enjoyed this video, please don't forget to like and subscribe for more such content in the future. Thanks for watching. Cheers.